So a catalyst is simply a chemical that makes a chemical reaction go faster without damaging or changing in the process. So the catalysts for these, for the catalytic converter, are the three precious metals. Okay? That when their compounds, the precious metal compounds, interact with the exhaust going over them, it has a chemical change effect on the exhaust gases, but the metals stay the metal, right? Doesn't change the metals. It changes the compounds as it passes over the metals. That's what a catalyst does. Okay? It's not harmed itself, but it causes a change. Okay? So the catalyst is made from platinum or similar materials, palladium and urodium. Urodium, not uranium. Urodium. In effect, 3 different chemical reactions occur in that catalytic converter at the same time. Okay, the early catalytic converters you had in the 70s automobiles and early 80 automobiles only had 2 reactions. We got a 3-stage reaction. Okay. The biggest problem with a catalytic converter is it's got to be hot to work. So there's a period of time there during warm-up, like you said earlier, Vanessa, that the car is extremely dirty. Okay. I had to tell my stepdaughter when she's warming up her car to open the door a little bit, because she'd go out to work, she'd start the car with the door closed and set her seatbelt and do all her things, and she'd leave and I'd walk into the garage and it's like, wow, whoa, because the car was not running clean because the catalytic converter was not up to temperature. Okay. So there's 2 reactions that take care of 3 gases that go on in the catalytic converter. Okay? One of the reactions tackles nitrogen oxide polluting using a chemical reaction called reduction. So the first chamber that my exhaust goes into in the catalytic converter is the reduction chamber, where we pull the oxygen out of that chemical we call exhaust and we make another chemical. Okay? So this breaks up the nitrogen oxides into nitrogen and oxygen. Now we've got 2 separate gases. Okay. Nitrogen in and of itself is harmless because we're breathing it in, right? 78% of the air we breathe is nitrogen. And of course, oxygen. The second reaction in the catalytic converter does exactly the opposite. So I take the exhaust compound that enters the catalytic converter from the combustion process and I remove an oxygen molecules from it. That changes that compound to yet another compound. Y'all with me? It goes into the second chamber and we add an oxygen molecule to it. It's called oxidation. Okay. So that turns carbon monoxide into carbon dioxide chemically by adding another oxygen molecule. And another oxidation reaction occurs which turns unburned hydrocarbons into the exhaust, into our carbon dioxide and water. 3 harmless components. 4, nitrogen, oxygen, carbon dioxide, and water. By performing 2 chemical reactions on the exhaust, it comes out of the tailpipe, relatively harmless gases. Oh, and of course heat. Okay? That's what the catalyst does. Now that extra oxygen that we need in the second chamber comes from the function of the O2 sensor, causing the fuel-air mixture to be purposely lean and purposely over-oxygenated. So the extra oxygen is stored in the catalytic converter and it's used in that second chamber to oxidize the exhaust compound. It's called oxygen pumping. So that's why if you look at a pattern for your O2 sensor, the O2 sensor works by creating electrical current in proportion to the amount of the oxygen in the air. So on an oxygen sensor, it has what they call a reference chamber. This is why you don't want to coil up your oxygen wires real tight and zip tie them, because the oxygen chamber uses outside air to sample against what's in the exhaust stream. And that air gets into the exhaust, that sample air gets into the sample chamber of the O2 sensor down the insulation of the wires. Most of your Yu-Gi-Ohs work that way. So by crimping the wires, you block that sample chamber and it skews your O2 readings. Okay. Now the O2 puts out a voltage proportionate to the amount of oxygen it sees in the exhaust gases. And it looks like a sine wave. So ideally, I would want my O2 sensor to produce 450 millivolts signal to the ECM. That tells the ECM that my combustion process is efficient. But if I don't vary the the oxygen content of the exhaust stream slightly, my catalytic converter won't work correctly because I won't have the excess oxygen available for the second oxidation chamber. So what the O2 sensor does, slightly rich, slightly lean, slightly rich, slightly lean, slightly rich. So when it goes slightly rich, the ECM is going to back the fuel off to get to here, and in the process there's going to be an abundant amount of oxygen for a period of time until it sees it being slightly lean. It starts to add fuel, subtract fuel, add fuel, subtract fuel, add fuel, subtract fuel. And this excess of oxygen created by the O2 sensor is what's used in the oxidation chamber of the catalytic converter. Back in the day, you'll remember this, Jeff, the smog pumps. What that did is it pumped oxygen into the